All right, so this is a good news, bad news day. Okay, so I got to talk, but you guys don't have any homework. Now, I'm going to tell you right now, you're going to have one assignment over gravity. And it's brutal.
Oh.
So I'm just telling you, enjoy your reprieve right now.
Is this
It's the
assignment
only
coming
assignment
tomorrow?
I'm going to give you, where I'm going to give you basically like 3 or 4 days to work on it. It's that much. So I'm telling you, enjoy your time while you have
And when
it.
is this being assigned?
Okay? It's on gravity and centrifugal motion and a whole smash. So I'm just telling you, so if you have other classes you need to catch up on, time management, because I'm not going to give you any homework tonight.
Code.
So if you have essays to write or whatever you need to do.
Do I 11 on Wednesday?
So, and we don't have school on Wednesday,
Oh yeah.
so.
It's a whole day to do homework.
Yay! Spend a solid
Okay.
12 hours on the assignment. I'm gonna die. 6 a.m. to 6 p.m.
It'll take you a solid 2 hours, not gonna lie. It's gonna take you a solid.
So
No.
No.
If it takes you 2 hours, it's gonna take
It's
us
gonna take
like
8.
8.
Oh, no, it would take me half an hour to do it.
Because you wrote it.
Yeah, I wrote it.
He wrote it, so he
I
knows all
want
the
you to know the
answers.
last, or all of these assignments that you've been giving us, I would say the average that everybody's been doing it for, both for Mays at least, is around 2 hours.
No.
2 hours.
Not
This one
me.
for 2 hours.
Not me.
Yeah.
This took me 2 hours. How much is this
That one probably took me like
6
2,
hours?
2.5. This one took
I
me
see
like
3 or
3.
4 hours.
I worked like 2 hours on this
After
yesterday
2
and an
hours
hour
of
this
work.
morning.
New York City.
Okay.
I'm not
Anyway.
really sure. I never.
Cohen, are we
how long
rolling?
it takes Yeah, me. we're rolling.
Okay.
All
All right,
I
so
might cry.
the cool part of this is that you need
Oh,
to
thank
view where we are at with gravity in the perspective of history, okay? So astronomy has been called the oldest of all of the sciences. And there's any number of reasons for that. One is philosophical. You know, if you look at all the great religions, regardless, there's 2 common themes that exist in all great religions. And they need to answer the question is that, how did we get here? And how do we live our lives? So regardless of what it is, Greeks, ancient Mayans, whatever, you had to answer 2 fundamental questions. And everybody kind of looked to the stars to find that. So there was a great book, it's called The Power of Myth. And it goes through and looks at the commonalities of all the religions around the world. And there's certain themes that play out. Even if you ever get the chance, go to the middle of the Australian outback. And there's a big rock out in the middle of nowhere. It's called Uluru. And it's cool because it's actually sandstone. So it was formed horizontally, but this rock got tilted, and all the seams are now vertical. So this rock, this huge rock, got tilted 90 degrees. And it's out in the middle of nowhere, like literally, the Australian outback is just as flat as you can be. And then out of nowhere, here's this big orange rock. So the Aborigines had this whole mythology about creationism and how there was a serpent and it swept some stars from the sky, and that's their point of origin. And so almost all religions have some tie with astronomy, because it's the million-dollar question. It's like, okay, here we are, you know, are we alone? Are there other planets? Are there other solar systems? Are there other galaxies? What's at the edge of the universe? So you get very philosophical, and you get very, very deep questions when you begin to contemplate these things. So you had a philosophical / religion aspect to it. And so for quite a while, and it was a fairly arrogant approach, we thought we were the center of the universe, okay? Everything revolved around us. And it made sense. So if I drop this, any weight, it falls towards the earth. Okay, if you go outside and you look at the motions of the planets, the comet, whatever it is, the moon, the sun, if you go outside and you make observations, it looks like everything is moving around us, okay? It does. And so that's why for a long time, we had a perspective of what we called a geocentric solar system. Geo meaning Earth, okay? Now, in contrast to that, you had the heliocentric. So that means sun-centered, and this is Earth-centered.
You got Earth, boost.
Okay. Now, if you let me kind of give you this idea. Like, okay, tomorrow or on Wednesday, because let's say we got the day off, so we're gonna spend the day making planetary observations. So we're gonna meet out in the parking lot about 8 o'clock. Sun's gonna be coming up, and we'll have pancakes and wet breakfast or Pop-Tarts or whatever. And we're going to see what's going to happen. Like, oh, we're going to see this faint glow of orange off in the east. And then eventually we'll see the sun start to rise. Cool. Okay, so the sun's come up. And we're going to just watch it throughout the day. And we're going to see the sun move across. Okay? And then about noon, this is going to be important, about noon, sun's directly overhead. So we'll fire up the grill and, we'll make sandwiches or hamburgers, whatever. And then throughout the afternoon, maybe take a nap, play some football, whatever. And then we're going to see the sun set. We'll fire up the grill again, throw shrimp on the Barbie, and we'll see the sun set. And I said, what did you all observe? And you all would say, well, we stood out in the parking lot, and we saw the sun come up over there, traverse across the sky at what would appear to be a fixed distance, and then you're going to see it set over there. I said, cool. Did you all move? It's like, no, we stayed out in the parking lot.
Well moved.
What happened?
My ankles playing football.
Well, we saw the sun move across the sky. Okay? Cool. And you would have the same sensation as if you were watching that rubber stopper. Okay? If you see this rubber stopper move around, you would see that rubber stopper appear on a horizon, go around like this, and then set. So that's what you would see. Okay? And if I said, I'm going to stand over here on this side of the class, and I'm going to walk over here, and I'd say, what did you all observe? Well, for camp, you walk one side or the other. And I would say, no, I never moved. I never moved at all. You all revolved around me. I was stationary. You guys were the ones that were moving. But that's the leap of faith that it took to go, ooh, the sun actually isn't moving. We are. And that was problematic. Because that means that to do that, and you had a religious basis in this. So if you go old school Genesis in the Old Testament, and that influenced a lot of the early philosophers. And they said, God made man in his own likeness, put us at the center. It was the most egotistical view of the universe and the world. Okay? It's like the ultimate freshman mentality. Literally, we thought the universe moved around us. Okay? That was the perception, is that they thought the universe moved around us. You might. Are we tilted?
Yeah, the cord slipped and it pulled on the camera.
Well, you might take some of that cord and like tuck it underneath that book. Take that tension off of it. Sorry about the camera.
It's Colin's fault.
What? I'm not
Yeah, Colin's fault.
It was this
Blame me
handwriting.
south.
Okay.
My handwriting. Yeah, it's Colin's handwriting.
All right. So it was this freshman mentality. We were the chosen planet. Everything revolves around us. The sun, obviously, even if you track the moon, okay, you see like last week we had a full moon. You saw the full moon rise. You saw the moon follow the exact same path as the sun, and it set. You look at the motions of the stars, the planets, whatever. everything appears to move around us, and it made us feel good. We needed it for navigation. Okay, so there was a book called The Longitude Problem. It's a fascinating book. So, in the days before GPS, and here's the Earth, okay, and you have lines of longitude and you have lines of latitude, okay? Latitude wasn't the problem, because latitude, you could use the stars like the North Star. If you're in the Southern Hemisphere, you could use the Southern Cross. And depending upon where you were, you could use the sextant and you can get an idea of how far away you were from the equator. That wasn't the problem. And it was called the longitude problem. So when you would set sail across the ocean, if you've never been out on the ocean, you have no visual bearing whatsoever. So they could keep track of if they were drifting north and south. Longitude problem was a huge thing, because longitude was how far you had moved from a particular landmass. Well, without any fixed points in space, you couldn't really keep track of that. And so in the 1700s, there was basically the royals of England actually offered a prize to solve the longitude problem. And so this became a whole deal of intrigue. There was a guy that developed a clock, and that's what they could do. Well, this is where they could actually use navigation. So, in terms of the stars, in terms of the planets, in terms of the moons. So they developed a technique, and it was actually relatively accurate. So Jupiter has 4 big moons, 4 of the Galilean moons: Io, Europa, Ganymede, and Callisto. And if they could figure out and make those observations about those moons, obviously that was very precise observations, they could use the relative positions of those moons to a chart, and they could get an idea of longitude, okay, where they were. It wasn't very accurate, but at least you had some idea. Well, that obviously only worked when you could see Jupiter. If Jupiter wasn't visible in the night sky, hey, you were kind of screwed at that point. So it told them when to plant, when to harvest, when was the Nile River going to rise, okay? So they use this as a calendar, okay? You look at why is a month typically about 28 days? Because that's about how long it takes for the moon to go through its orbit, okay? You look at why is a year 365.25 days? Because that's how long it takes for the sun to go around the earth. Cool, okay? So a lot of our time, and our calendar and months and all that good stuff is based upon observations of planets. So for a long, long time, we lived under the geocentric idea. It fit, it made observations, we were cool, it made us feel special. But here was the problem. There were observations that didn't make any sense. So no matter the model, you had to deal with what we call retrograde motion. Retrograde motion was very problematic. So if someone says you listen to retro music or you dress retro, what does that mean? Old. Oh, you went back in time. Okay? Ooh. So what would happen in retrograde motion is that you would see Mars, for example. Mars had a very observable retrograde motion. And so what you would see is that over a period of time, you would see Mars change course. Now, let me get rid of a couple of misconceptions right now. This is not something that happened in one night. It isn't like you were watching Mars, all of a sudden it stopped, and then it went backwards, and then it started going forward again. Okay, if that happens, there are so many other issues. So, one of the things that you have to keep in mind is that how do you judge the positions of the planets? So, if you look at the origins of the word planet, it comes from the Greek word meaning wanderers. So you have a fixed area backdrop of stars. Those don't change. You look at the Big Dipper, you look at the 3 stars that make it the Belt of Orion, all of these different constellations. So what would happen is that you would, and we'll get into this and how Tycho Brahe did this. If you look at how they judged the positions of these stars, it was always against a fixed backdrop. So it would be like, hey, I need to figure out, like, where's Preston? Okay, I'm looking at Preston, and Preston is just to the left of the constellation roller coaster, okay? Or he's just like 2 fists to the right of the constellation ladder, okay? And he's just below A in the constellation F equals MA. So I have these fixed points in my room. And the only thing I can judge the position of Preston by is where he is. Now, Preston, here's what I want you to do. I want you to stand up for a second. And I want you to slowly walk this direction. Okay? Keep going, keep going, keep going. All right, stop. Now, so when they were watching Mars, and again, this did not happen in one night. So what would happen is that Mars, like everything else, moved on an east to west trajectory. So over a period of time, I would see Preston, which is representative of the planet Mars. Relative to the background stars, Preston is moving to the left, okay? The overall movement of the stars is still east to west. Now, at this point, Preston, I want you to walk in the opposite direction. Okay, now, stop. This point, this is retrograde motion. Preston and the stars are still moving east to west in the night sky. But Preston, relative to the constellations in the background, Preston is moving back this way. And that might take like a couple of months. So Preston, relative to the stars, had been moving in a particular direction. Still, everything's still moving east to west. But then he's going to stop and he's going to go back this way for a little bit. Now, I want you to move forward and go back this way. Cool. Okay. So what Preston just did, now we're good. You can sit down. So what Preston just did is retrograde motion. So we would look at Mars and we would see Mars relative to the constellations continuously drift in one direction. About every 2 years, it would stop. It would come back, stop, and then move forward again. And they got very good at predicting this. They could tell you exactly when Mercury, Venus, Mars, Saturn, whatever, was going to go in retrograde motion because they had had years and years and years of observations. So in the geocentric model, they would say, here's the Earth, and here is Mars, and Mars is trucking along like this, and life is good. But how they would explain this retrograde motion is they would say it would go into what was called an epicycle. And so Mars would get pulled out of its normal orbit and go around in this little circle, and then it would come back here, and then it would return in its normal orbit. So that's one way I could explain the observation of Preston. So if Preston was walking, and then he goes, I think I'm just going to take a little circular stroll. And Preston would go and he would walk in a circle, like this, not very big. So I couldn't judge that he was walking in a circle. All I could tell was that Preston stopped. He moved back in the opposite direction. He stopped. And then he continued in this way. It's like, okay, I've had my little path. I've walked my circle. Now I'm going to go forward again. So no matter what the model was, they had to explain retrograde motion. Sometimes you'll see shirts like, say, Mercury is in retrograde or something like that. Venus is in retrograde, whatever, okay? Or if you read your horoscope, which if you do, I'm just going to flunk you all. And it'll say, oh, Mercury is in retrograde. You will find romance or whatever. Like, okay? God. So no matter what the model was,
I'm curious, let's see what
they had to explain this retrograde motion. And one of the things that they had to figure out was, first off, which model were we working off of? So, one of the first big hitters on this story was Nicholas Copernicus, okay? So Copernicus was a Polish monk, which means that he worked for the church. So Copernicus was the first one that came up with like an actual scientific paper supporting a heliocentric solar system. He put the sun at the center. So he really didn't want to deal with the church because he was a monk. So he actually requested that his paper not be published until after he passed away. He goes, it's a well-written paper, I'm going to lay out this argument, I don't want to deal with it, just have it published upon my passing. And he did. And so that was the first real scientific explanation that supported a heliocentric solar system. So that was kind of the first shot across the bow in terms of what kind of solar system we would have. So the next big player, and I'm not going to expect you to know this, was this guy by the name of Tycho Brahe. So if you look at all of the unique characters that make up the history of science, Tycho's on my is like on my list of like guys like if I could go back in time and hang out, I'd go back in time and I'd hang out with Tycho. So Tycho was Danish nobility, which means that he basically didn't have a job. So no, it's true. He was noble, didn't have a job, and off the north coast of, I think, Norway or Denmark, I don't remember which country, he built on a small island his own observatory. Now, this is before they had developed the telescope. So, if you ever want a cool research paper, if you're in college, like, hey, write a research paper, look up Tycho Brahe. Because he built this huge and very intricate, basically mechanical system to track the motions of the planets. And he did this for literally decades. He had volumes upon volumes upon volumes of documents that recorded the planets, where they were, when they rose, when they sat, where they were relative to the constellations. He had the mother lode of data. Okay? So that's what he was famous for. That was one thing. He's also known as the gold nose guy. So according to legend, he was Danish nobility. Back then they took their math very seriously. You think you guys take your math seriously about like the radius? So supposedly, according to the story, Tycho and another nobleman got into an argument over mathematics and how to solve the problem. Tempers flared, swords were drawn. They got into a sword fight over how to solve this problem. They thought you guys didn't. And according to the legend, Tycho got his nose cut off in the fight. And Tycho, being of Danish nobility, didn't want to walk around without a nose, so he had a gold nose fashioned that he had. And so he was like the original bling. So that's why sometimes when you see pictures of Tycho Brahe, you'll see him with a gold nose. So he was famous aesthetically for the massive handlebar mustache and the gold nose. So,
sick.
Tycho Brahe,
The ultimate rip.
and this is important, he had decades of data. Because, like for example, if you go out tonight, well, it's going to be cloudy, hopefully it's raining tonight, but if you go out, you can see Venus. Okay, it's low on the western horizon. It's really the brightest object in the western horizon. And so, but it isn't like you can just look at Venus and go, oh, clearly Venus is 10 to the 6th kilometers away. Oh, I got that. Oh, clearly Mercury is inside the orbit of Venus. And we can just look at planets and go, it isn't like a rangefinder on a golf course where you can shoot a laser at it and go, oh, this is how far away it is. Got it. Okay? So it took years and years and years and years and years of data to try and figure out the motion. So Tycho, being of Danish nobility, actually came up with his own solar system. It was called the Tychonic solar system. Tycho kind of blended different ideas. It was a combination of a heliocentric and geocentric. So we had the Earth orbiting the sun, but he has some other planets orbiting the Earth. So he kind of blended these ideas, and it was literally called the Tychonic solar system, because he just named it after himself and says, oh, we'll call it the Tychonic solar system. And he kept that idea of the epicycles, where they would go in these little epicycles, because that's how he would explain retrograde motion. So here's the stage. Copernicus has come out, published the paper, said, hey, we're a heliocentric universe. Tycho has collected years and years and years and years, volumes of data. He's blended the two ideas, said, hey, we're in a Tychonic solar system. Now, the next big hitter
Swing better.
is a guy by the name
Galileo.
Yes.
Johannes
The amount
Kepler.
of data
Oh,
that we've
Kepler.
gotten from unemployed people is ridiculous.
What's Kepler's first law, Colin?
An object at rest.
let's go.
For every action, there's a planet.
So the next big hitter in the story
Nuclear.
is
Captain.
Captain Nuclear is his full name.
Johannes Kepler. So he's another one. I don't know if I could go back in time, I wouldn't necessarily hang out with him. He's a weird duck. He was known as a wandering mathematician. He was from Germany. But Kepler's story, and to really understand what Kepler did, you have to understand his mindset. So Kepler's worldview, he was put on Earth like I'm on a mission from God. If you've ever seen the movie The Blues Brothers, if you haven't, it's a good movie. And Jake and Elwood, the two main characters, that's their famous line in the movie, we're on a mission from God. So that's literally what Kepler thought. In his mind, he was placed on Earth, and this is important later on, by God to find a mathematical way to describe the motions of the planets. Okay, that was his calling. His famous statement was just like, as a songbird is put on Earth to sing, I was put on Earth to do math and to find these laws to describe the motions of the planets. So,
Well, did he?
Kepler knew that he needed the data. So he hears of Tycho Brahe. So he goes to Tycho, knocks on the door, says, yo, sup, here you've got data. He likes the guy. He says, yes, I do. They hang out. They actually do some research together. And then Tycho says, hey, upon my passing, because he was older at this point, he says, upon my passing, I want Kepler to have the data, because Kepler went to him and said, I'm on a mission from God. I need your data, because Kepler knew he could not live long enough to make all the observations and get all of the data and do the math. So he needed a head start. He needed Tycho Brahe's data. So Tycho passes away. Kepler shows up, knocks on the castle door, says, yo, he said I could have the data. The family, according to one story, says, nope, we're going to keep it. It's a family heirloom. We want to keep the data. Can't have it. So at this point, Kepler is faced with one of the great moral dilemmas that ever existed in science. He goes, I'm on a mission from God. I've got to have the data. But they won't let me have it. So at this point, he's weighing his options. He goes, I could try and find some other data, but it's not going to be as good. I could collect my own data. I don't have time because I'm not going to live long enough. Or I could storm the castle, steal the data, and take it back with me. So that's his quandary. So according to the famous quote, is that Kepler advanced science over ethics. So according to the story, this is like a Mission Impossible thing. Play the background music. And so he breaks into the castle, steals the data, and escapes back to Germany. So now, Kepler has all of the data. And so now he can start, okay, you get it. So Kepler can now start the analysis. But before we start that, we need to figure out what type of solar system that we live in. So, here's the Earth, okay? So the first thing that we need to decide is that if you look down on top of the North Pole, where Santa is, so here's the North Pole. So the first thing we need to decide, does our Earth spin clockwise or does our Earth spin counterclockwise?
Those arrows point in the same direction.
Huh?
Those arrows point in the same direction.
Okay, my bad. That's a valid point.
Does the Earth spin clockwise or also clockwise?
Clockwise.
Okay.
Or counterclockwise. There we go. I said that and then drew the arrow. Okay. So that's the debate. So, what time does he leave? You still got it. Okay. So we'll get through this and you can go. So, you're looking down from on top. You got a 50-50 shot. Clockwise, counterclockwise. Gap Sean.
Counterclockwise.
Why?
No,
It depends on the hemisphere.
because this is the.
No, we're looking
Bro,
down
the Earth
from
spins
on
like
top.
this.
We're looking down from on
Oh, on
top.
top.
It's
Okay, on
unscrewing.
top. It's counterclockwise.
Why?
I don't know. Just guessing.
I think the sun rises in the east. So
Valid point.
Yeah.
So,
What is the
So-
motion of the,
Cohen is our sunshine.
Yes!
Okay? Here we are, we're a penguin
He gets
at the
cancer.
equator, right here. Cohen is the sun. What time of day is this?
noon.
Noon. If you're over here, it's midnight. So here we are. Let's shift up to Maze America. So when I come around like this, right, I see the sun rise in the east. So that's why we spin in a counterclockwise circle. I know you guys need to go. We'll take this up tomorrow. Remember, counterclockwise. That's what it's
I was literally right.
Counterclockwise.
All right, let's
If you
stop
do
you
it
on the
50,
camera.
Cohen.
Like, my